So welcome to the Aero subteam. I'll just give a quick overview of what this subteam is all about and a little setup with the softwares that we use. So what is the Aero subteam and why do we exist? Well, it can be really hard to know how a plane is going to fly before you actually build it and fly it, at least in the case of a model aircraft. And that's one of the ways that, one of the problems that Aero tries to solve. So we will analyze the plane design, take a look at its geometry, its mass, and other things like that to try to determine how will it fly, what kind of design features do we want that will help it fly better, like what airfoil is best, and where might we possibly run into problems. Maybe we'll discover that the plane is extremely unstable, or maybe it has a high risk of stalling, things like that. And how do we do it? We use a software called AVL, Athena Vortex Lattice. And that was a software written at MIT a while ago. And it is kind of the standard in terms of like university level model aircraft analysis. And it works by the Vortex lattice method. That is essentially an approximation of the plane's surfaces that uses infinitely thin vortices. I would recommend checking out this link to learn more. And just to note, it's a little old, it's a little jank, but it's extremely useful if you learn how to use it. And so a little more about AVL. This is a link to download it. That also has access to the documentation, which is a little dense, but if you get stuck, it's a good place to refer back to. Here's a link to some of our example files that you can use. We have a .avl file, which is the geometry, a .mass file, which is the mass of the plane, a .dat file, which is an airfoil. We actually get these from some sources online, and this supports our geometry file. And then not listed here, we also have a run file, which can set the conditions for flight. Next, you're going to want to load them into AVL. And finally, you're going to want to profit. And so I'll give you a quick rundown of how to do that in a second. But there's also this Going Deeper link, which I would highly recommend checking out. It'll tell you a little bit more about how to define these files and what sorts of analysis you're able to do. So here's just a quick look at AVL. This is what you'll see when you open it up. And I would recommend creating a folder to put AVL as well as any of the files you're going to want to be using. And so you'll start off by loading the geometry by typing load. And then you'll want to type in prototype 12020 or whatever the name of your geometry is. And then next, after that, we'll load in the mass. Oops, sorry. You're going to want to type mass first and then enter the mass file name. Let's try prototype. And then now that those two are loaded, you can type oper to see what kind of commands you can run. And one great check that you can do right at the beginning is type G to take a look at the plane geometry. So this is what we have defined. And then next, if you want to exit that, you can type Q. And then if we want to run a case, we can type F. and then type in the file name. I have pcruise.run, so p_cruise.run, and then this will sort of open the door to a lot of more analysis that you can do, get an idea of sort of what constraints you have. And if you're interested in doing a little more of that, or taking a look at how these files are designed, they have a very specific formatting here. I would recommend checking out the Going Deeper video.